And we're back. It is COMP392, that's Advanced Graphics at Centennial, week 9, part 3 of our broadcast. And what we're going to be talking about today is how we're going to finish off player movement. And let me just bring up the project we're working on last, right? So working on this project, lesson 9, COMP392 lesson 9, that's the project we're working with. So I made a couple of changes just to fix what we had from before. So if you look at, we had a couple of actual typos that we had. So if I go back down to our game loop here, you can see how direction is now being defined here in line 274 of our game loop. It's inside of our game loop. And let's just see what we've got so far. I think it's important for us to always review where we are, and then take a look and see what we need to do from there. Please bear with me as I'm still recovering. Okay, so where we were last, we did this. So we kind of press click to play, our object falls, and then we can move forward and back to back. So if you actually look at the code that I've got in there, if I turn the camera, it'll go in the right direction. The mouse will move now in the direction that that I want it to go. And I use a very simple formula to do that. We'll just review. So it'll actually move in all directions, jump and so on as well, right? Still falls a little slow for my liking, but that's just me, right? Let's review what it looks like. So if I take a look at what where we were, we have a series of if statements here. And again, I mentioned how it's inside the if is grounded if statement. And the reason for that is if you don't want to move if the object's not grounded. So what you're doing here is I've got these console commands that I'm going to remove now. I think we've tested like forward movement and so on a while. So I'm just going to get rid of some of these console commands for movement. It's clutter. It's a bit of clutter for me, right? I usually put them in for debugging purposes, but now I'm pretty comfortable with the way things are moving right and left, so I can take them out. Same thing with jumping. Okay, so we've got our is grounded, and if you look up online, the latest version is up on GitHub. So we've got player position.y is greater than 4, and the reason for that is because if the player jumps beyond a certain point. Now that is not a perfect way of kind of changing from is grounded to not grounded, right? We got to figure that out. How do I change if I've left the ground, if I move off the ground, if I've got any kind of momentum at all in the Z or the Y direction, sorry, that means that, I've left the ground. I don't have a contact between the ground and the player anymore. And there is no way of knowing that. There's no way of understanding that as far as we know. However, one thing to note about collisions is, and about PhysiJS is there's a bunch of stuff that's going on. Let's take a look at PhysiJS. I go to PhysiJS collision, right? And I look at collisions under the PhysiJS API, right? Let's take a look now about what it says. It says collisions are currently handled with the object level collision events. These events pass 4 parameters. The other object being collided with, the difference in velocity between the 2 objects, essentially the speed of impact, the difference in angular velocity, the contact normal between this and the other object. Those are the things that are being passed, right? So really at the end of the day, that's all it's passing. It doesn't pass things like, did I leave? Am I still colliding? Nothing like that, right? The other things to note when you look at the event object, like I looked at before as an example, right? So if I go back to my collision event that I have, it's a very simple collision event here up the top that we kind of made right next to the player. So here's our player, and then here's our collision, and we can tell the difference between colliding with the ground or colliding with the sphere. And if I was to see what we did last time, remember what we did? We said, let's take a look at what this, if I do console.log, and if I just put in the event by itself, this is interesting because when I go back to this, here's my event. Notice how, it's falling still, right? Let's take a look at the inspector and see what's going on. So here's onto the console. You can see that I've got this, here's the scene, player hit the ground, and then I got this other event here, right, where it says PhysiGS convex mesh, right? So if I actually look at this thing, it says, here's my children, my geometry, material, PhysiGS material, and so on, and the name is the ground, type is mesh, and so on. That's what it says, and it says player hit the ground, and I hit the ground twice, right? So here's hit the ground first, here's my event, right, and then here's the second event. So these events, right, actually do return a lot of information, right? Things like the children that it has, length of 0, are there any child objects that are returned? Material, the matrix, there's a matrix for different kinds of information as well. I'm not really sure what we can do with that one right now. Things like the parent, so it's the parent is the scene, the position. This is interesting, position is 0, 0, 0, right? Quaternion also returns 1, 0, 0, 0 in terms of rotation and so on. There's just not much information in terms of what we can get from it, right? User data for the object, the UUID, is it visible or not, and so on. So that really doesn't give us a lot of information about leaving the ground. We don't have other events like we do in something like Unity, where we can say things like on collision, leave, or exit, on collision, exit, or one of those kind of things, right? We don't also have the ability for us to know when we're not colliding, right? We don't have the ability to do that, not by chance, like either a collider is colliding or not, right? And we don't have different kinds of colliders. We can't, it's not like we can create a collider that's like an edge collider or some kind of mesh collider that goes around it or whatever, right? One thing we do have is we have the ability to measure distance, right? So we know the distance between the two objects. That we can know, right? And that might give us a clue as to whether or not we're colliding or not, right? We can also do that as well. So if the distance between the two objects is half the distance, half the height of both objects again, right? Less than half the height of both objects or equal to half the height of both objects, you know that they're on top of each other, right? Half the height of both objects, no problem. So that's one thing we can definitely do. And same thing goes with half the, if it's less than half the width of both objects or half the depth of both objects. Those are the things we can always take a look at to determine if you're colliding or not. But again, so when you make your game, this is due on Friday. The second part is due Friday. Remember that your collisions are very basic, the way they're handled right now with a simple event. Am I touching or am I not touching? That's all I know, right? So anything you do from there, you have to create your own structure from that, right? And there's some tricks we can use to make it easier. Like, for example, if I'm using a collide against a coin, I'm going to pick up a spinning coin that's in front of my face, right? I'm walking and I pick up a coin, I bump into a coin, I pick it up. Well, I can detect the bump. When I bump into it, that's just simple. So I can do things like pickups. I can do things like player damage, right? I can make invisible places to fall into, right? Because I don't have to display them. Those things like traps and pits and all that kind of stuff, easy to do. But if you're talking about more advanced kinds of collisions, that's when we get into trouble, right? That's when we're going to have to be creative in the way we do some of our game mechanics. So Friday, game mechanics means collisions, basic collisions with your world in general, right? Do I need points or scoring? No, I don't. I do need an updated external document. So please update your external document with screenshots of the world that you're in. Your game does not have to be complete in terms of like, is it fully functioning, like the whole game giving you points and feedback and all that kind of stuff. It's not required. The only thing I ask is that your basic movement is there, so the stuff we're working on right now, right? And basic collisions. So if you have a maze that you've created, as an example, then you should be able to bump into the walls or go on top of the wall or whatever it is with your object, right? And we have to talk about that too, because we've done our basic jumping. Remember, jumping means that if I'm grounded, I can jump, right? If I'm grounded. But grounded means something different, right? I have to make sure that I'm grounded if I'm on other objects too, not just the ground, right? And also I have to detect when I'm not grounded when I jump. If I jump up, I'm not grounded anymore, right? Or if I fall, I'm not grounded anymore, right? So I've got to figure that out, right? If I'm not colliding. Okay. It's almost like I'm missing a collision on complete when I'm not colliding anymore. And we can figure that out by looking at some of the source code, but it becomes more challenging to do all this. Okay, let's take a look here of what we have to do now, what we have left to do. So what we have left to do is this. We can move around, we can move in a certain direction, and the way we accomplish that is inside of our game loop at the bottom. Here's what I've added in. I've added in this set damping thing. Set damping damps the linear and angular velocity, so I can dampen it up. It means what it does is it reduces the speed, or it keeps on chomping at the speed until it stops, almost like adds resistance, if you will. So that's kind of cool. We've set our angular velocity for our mouse controls for yaw, right? So as I turn left or turn right, I have my, depending on which way I'm turning, then it sets the angular velocity of where I'm going. That's kind of cool. I add vectors for my direction. I say, well, let's determine my direction. It's a vector 3 object that starts at 0. And then I add 2 vectors, the 0 with my current velocity. And then what I do is I apply a quaternion change. So whatever based on what the player's location is, right? And which direction I'm facing when I turn my player, I apply that to the direction, and then I take that that direction as a vector 3 object and apply the central force. So what I'm getting is 2 different objects from 2 different locations to create my motion, right? That's how it works. Okay, so I'm giving you the code here. This is a little bit, again, I was experimenting to how to get this to go, and this is the way that works best. Okay, so player objects. Okay, but we really haven't tackled a couple of things that we need to tackle in order for us to make our motion work. And we haven't done things like, well, I want to make sure that the camera is there, right? The camera is there. It's not so far the player moving around, and I've got left and right movement for the player, so to speak, right? But it's not really my camera. I don't have a first-person perspective like I'm hoping for, right? That's not happening right now. So I want to do a couple things to make this change. One thing is this is getting pretty cluttered up here, right? This whole game loop thing. And what I always like to see is once I see this piece, if keyboard controls enabled, and I go all the way down to the bottom, right? So here at the bottom here, notice that this is here's the if statement for the top, right? Here's the if statement for the very top for keyboard controls, right? So this is the second opening brace, if you will, right? And if I go down, it looks like this is the bottom where keyboard controls enabled or done. So I can probably take this whole thing here, right? This whole thing here, and cut it out. Let's do it together, right? So I'm going to cut this whole piece out. And now this is what it's going to look like. I'm probably going to have to take this too, yeah? Previous time is equal to time. And I wonder if I put that in a different place than I did for you guys. Yeah, let me undo that for a second. What I actually did in my other example is I only put this in I only count time when my controls are enabled. And this is something different. So I'm going to take this, I'm going to put this in here. So between is grounded and when my controls are enabled, because remember that the only time that I register it is when my controls are enabled. I kind of declare my variable here. So therefore, I might as well only do my calculations here within when my controls are enabled. All right, so let's just grab this whole stuff, this entire piece here. So cut it out. And I want to create something else, another function that I can refer this to kind of encapsulate everything, right? So I'm going to call this function, you know, check controls, right? So here's my check controls function, right? So I'll say function, right? We'll call it check controls. Remember, this can be incorporated into your player object when we eventually create the player object. Here we go. I'm going to cut and paste everything in there. Here's my check controls function. Format that code. And now inside where, just under stats, I'm going to put in there check controls, right? That's cleaner to me, right? So I've got my game loop now. Here's my game loop, right? And then I've got a separate check controls function. And all I have in my game loop is this. I think that's neat. That's like, you know, cleaner, right? If I go back to my example code, right, or my example here, notice I'm still moving the same way. You should have this kind of motion with your character now. Right and left, forward and back, you know, jumping, and this kind of simple motion with your little scope. And again, I like to look at this, you know, my little directional line as a piece of debugging that I'm using just to detect which way I'm looking, so I can kind of know that I'm in the right direction. Okay. So that's like number 2 that we've done. I want to start doing things with the camera. I remember what I told you. You can't completely pair the camera to the player for all motion, right? Well, here's what we can do. I can't modify the player's motion, right, with the X on the X, you know, like from an X angle perspective. So if I'm pitching my character back, that's kind of weird. My whole character will pitch back. I don't want that. I just want my camera to pitch back so I can look up and down with my camera. That I want to do, right? But since the camera, if I make to the camera a child of the player component that I'm adding in here, the player object, it will move and rotate. Example with the player, with the actual player object, the camera will move and rotate. Guys, by the way, and girls, it'll solve problems if you do this. If you actually pair the camera object to the player object, it will solve some problems. However, it will create new problems for you, right? So, for example, let's say I said I want to follow the player, and if you were to do this in something like a Unity or another physics-based engine, you'd be okay. If I was to say, you know, example like this, camera.rotation.x is equal to player.rotation.x. That would be fine. You would assume that in your mind, everything's okay. Please don't try that here, right? Player and camera, player being a physics object, camera being a non-physics object, will give you some weird ass, I'll say it just like that, effects, where you'll turn your head, right, with your player, and as soon as you turn beyond a certain point, like looking behind you, all of a sudden you start going the other way, okay? Just FYI, because it's almost like, because your rotation, remember we're talking about radians, so there's going to come a point where it'll go from negative to positive, right, behind you somewhere. And then what happens is, if you relate this to motion, it'll just rotate back the other way, right? Well, it'll be a weird effect, right? Whereas if you pair your camera to your player for most of the motion and the positioning, right, it'll be okay. The only thing I don't want you to do is use your pitch controls to pitch the whole player back. That won't fly. That won't be bad, right? You just want to pitch your head, which is the camera, right? Which is different. So we can change the camera separate than the player. Okay, let's do the pairing the player to the camera to the player thing first, to get a sense of what that looks like. If I look at the camera, remember I set the camera up near the top of my init method, right? So here's my init method or function. And down as I go through my spotlights and my ground and everything, I got my player geometry here. And this would be a great place just after we do our event listener for our collisions to kind of pair or even after my directional line, doesn't matter, somewhere, just be below or above my sphere geometry. It's a good place to pair my camera to my player. So I'm going to say, I'll do that. I'll say create parent-child relationship, parent-child relationship camera and player. Okay, so here's how we're going to do it. We're going to say like this: player dot add camera. Okay. Now, we already have some stuff we have down here on the bottom, right? Because remember, we set up our camera down here, and one of the things we do normally is set up our position and what we're looking at, these two values. Please comment these out, all right? If you leave these the same, some weird stuff is going to happen, all right? So just comment these out, these last two lines inside these. Okay, cool. Let's see what happened just by doing that. So I'm pairing my camera to my player. Now take a look what I got, right? I move around, I rotate, take a look, right? And now I've got some basic movement. I've got a bit of shake too. Do you notice that? Why is that? I've got some friction, right? But generally, I'm able to move around my player, right? Around the board, let's say, without any issues. You should have that too, just by doing that. From where we have right now, we can move things around. You won't have the guideline. Why is it we don't have the guideline? Anybody? It's only two-dimensional, right? It's can't see it's right in front of us, right? It's like it's literally we would just see a dot. It would be a single pixel, right? The only way you'd be able to see that guideline is if it was going from an angle, like if it was actually ported at an angle to you somehow. There are other ways we can do things here. Like, for example, I could create something else, right? That is going to be showing up all the time, an overlay, if you will, right? But for now, what I want you to think about is that the player movement is where we want it to be. Okay, from a left and right perspective, let's fix up and down now, right? Well, I want to kind of create this camera look. We'll call it camera look method, function, whatever you want to call it, right? You can call it camera follow or whatever. It should be another method. So it's going to be another function, let's say, underneath this check controls function. So let's start writing it before we add it, right? So we'll do something like this. We'll say function. This is our camera camera look function. That's what it is. And what I mean is look up and down. That's what I'm talking about, all right? Our camera look function is just a regular function that we're going to call, and we're going to call it camera look. And it's going to return void, of course, because it's not returning anything. We're going to declare a couple of variables, and please try and bear with me when I made these names, because when I was doing the names, I was a little bit sick. Right, so over the last couple of weeks, I've been kind of in and out. So just bear with me. I'm going to use the same ones. I'm going to call the top of the characters when I look up with the character, it's going to be called the zenith. All right. That's the zenith of my rotation, if you will, which is going to be a number. I'm going to use a special function built into 3JS. We're going to say 3.math. Degree to radians. Degree to radians. We're going to make it 90. So 90 degrees up, that's our zenith, right? And we're also going to create something else called a nadir. Nadir. Right, which is 3.math degree to radian, and again, just to show you, it's minus 90. Right, so 90 and minus 90. I don't have to do this. I could have just said zenith minus, right, or whatever. But let's just leave it the way it is, just to show you. I want you. It also does radians to degrees. So instead of you trying to manually figure it out on your own, I figured that they had a function, and yes, they did, right? Which we need to do that. That's like really, very, very, very useful function, utility function that they included in the library. Okay. So that's the first thing. We decided on the numbers, right? And then what I want to do is I want to create almost like my camera pitch. And I know we have something else called mouse pitch. But I want to call it camera pitch because that's what we're really doing. We're moving our head or our camera up and down. All right, so let's make another variable. And I'm going to do this every time we do a camera look function. We're going to calculate this stuff. By the way, I could make this global because I only need to calculate it once. But for now, it's okay. It's only going to be, it's going to live and die in this little function here, so it's okay, right? Again, there's some other ways we could probably write it to make it a little bit more effective or efficient. Okay, so I'm going to call this new variable, give it a little bit of space here, camera pitch. So our camera pitch is going to be a number, and this is where we get a little funky. We're going to start like this. It's going to be equal to our camera.rotation, right, dot x on the x-axis, plus our mouse controls dot pitch. Okay, let's think about that for a second. What is that? Camera rotation on the x-axis is in radians, right? Plus pitch, which means if I'm moving up, I'm going to get some kind of number that I'm going to add to the radians, right? And it's going to pitch me up, right? And if it's the other way around, if the pitch is negative, it's going to add a negative number, which means it's going to subtract, right? So it's going to pull down. So if I pull down, it's negative. Push up, it's positive, or the other way around. And it's going to create that positive and negative pitch. Okay? Cool. So I've got the way to move up and down, right? Now what I want to do is I want to say something like this. Camera rotation on axis. Rotation x is equal to camera pitch. Hi. I'm looking at the camera rotation at x here. What is this? This is what this is going to be next round. So I started off counting. So every frame, I'm going to take the original rotation and then add up my new pitch, whatever that's going to be, onto it. And the reason why I want to do that is because I don't want to say camera rotation.x plus equals. I don't want to do that here because I'm actually, it's going to be too much. And this is the right way to do it. Basically what I'm saying is take my original or my old rotation and then add pitch to it. Add where I'm going to be up or down. Okay? So I'm not going to start from 0 again. Solve some problems again. Okay, this is cool. You know, camera.rotation is what's saving me, right? Camera.rotation.x. This is which is okay. This piece is okay. One thing I'm going to run into though, and I found out through testing that this was happening a lot was, and this is something that I want to maybe put in here into my where I did my other control, where I did my check controls method. Here's my check controls method, and I'm going to call my camera look method from my check controls method. But I find that every frame, what ends up happening is, so here's where grounds ends. So when is grounded ends is where I want to check my camera control, right? So after I do my movement, in here is where I want to do my camera look. So I'm going to do my camera look. I call my camera look from in there. That's cool, makes sense. But I find that I want to be able to reset my mouse controls, both pitch and yaw, every frame. And this is again through testing. I've done this through testing, so I'm giving this to you as a gift. I'll tell you right now, this is hours of testing for me to get to where we are right now. Believe it or not, and it's a pain in the ass, and I think that's why I've got a headache today, right? But I'm telling you this because think about it this way. If I keep on adding pitch, I'm going to go like this. I'm going to completely flip off, right? And I don't have a constraint right now. I'm going to put that in a second, but let's do this. After our is grounded ends, every frame, regardless of whether I'm grounded or not, what I want to do is, and just down here, before previous time, I'm calculating previous time is equal to time, right? Calculate my time sync, right? I'm going to reset my pitch controls, so my pitch and yaw. I'm going to reset them to 0. So I'm going to say mouse controls dot pitch is equal to 0. There's every frame. I'm going to do this, right? And mouse controls dot yaw is also going to be equal to 0. And the reason for this is if I do this every single frame, I'm going to enable myself to stop stop the movement. Let's try this out. So I look up. Whoa, what happened? Whoa, ooh, oh. How come I'm moving so fast? There's no, first of all, it's way too fast. Like this is, I'm doing it. It's doing what I'm asking it to do, but I'm also not constraining myself. We're almost there, guys. So let's add those pieces in. I found that when I'm yawing to the right and left, because of the natural resistance of the ground, right, and my player is running against the ground, my sensitivity, which I've set at 0.1 from my mouse, and I'm just going to go back to my mouse sensitivity for a second. Let's just look at that. And that's in another file. That's in our objects.mouse controls, right? Remember, I set my mouse sensitivity, to 0.1, right? And that works great, you know, from a player moving perspective. Where it doesn't work great is pitch, because pitch, it's the camera that's moving. And nothing's limiting that camera from moving. It's just going to go like wacky, right? So let's multiply this by 0.1 again. And I'll tell you, we're going to really dampen this down. Times 0.1, all right, for pitch. And the reason that's going to really reduce it a lot, and that's probably about right. You may think this is crazy that I'm saying, okay, so it's 0.001 is what I'm saying, right? In terms of sensitivity. Guys and girls, right? For me to get to this point, to tell you that I have to reduce it, it's been tested. Tested it like over and over again for me to get to this point. That's why it is, right? Remember, I've made this from scratch with you guys, right? It's not like we have a library we can pull from and say, hey, let's just drag and drop a player control. There isn't anything like that that works for us, right? We're making something new here. Okay, so this is what's going to work. That's number one. Two, let's get back to our game now. So once we've added that extra piece of resistance, right? Oh God, there's a pun in there somewhere. Let's add some constraints here. So how do we do that? Well, I want to do something like this. I want to say, I got my zenith and my nadir, right? I kind of planned it out already, right? And well, here's how I can do that. I can say, here's my, I'm going to constrain the camera pitch. Okay, that's cool. And there are some, if I do something like this, if I look at my 3.math, look, I have a clamp. I have a clamp thing. And clamp, what it says is I have a value, right? Here's my value. And I have min and max, right? That's what it does. And it returns something, right? So look what it returns. Here's my, if I look at if I zoom in there, it says my method is math clamp and returns a number, right? And all this is returning is a number between something and something else, right? So clamp. And clamping is really cool because it's like using mathf clamp in Unity. Who remembers how to do that? Anybody? Some people may have done it, yeah? Mathf clamp in Unity is the same thing as what we're doing here. We're taking a value, we're saying, give me a minimum, maximum value, and if it falls within those two values, you're golden, right? So let's try this out. So let's say something like this. I want to say that my rotation, right? Instead of my rotation being my camera pitch, that doesn't make any sense, right? I want to be able to limit myself from a minimum and maximum value, and I can do it in one line. So let's take this little comment here and try it out. So comment, put it over here, and then what I want to do is get rid of the, take that, keep that in mind where I do my camera pitch. The camera pitch is the number, right, that I want to get. So I want to do something like this. So 3.math.clamp, and then I'll say camera pitch. Here's my camera pitch. And here's the minimum number. What's that number going to be? Minimum, nadir, right? And what's the maximum number going to be? It's going to be a by zenith. Now here's a problem with this. Well, I like the idea, right? Number, zenith, and if I spell it properly, here it is. What numbers am I going to get here, right? Camera pitch, and camera pitch is the number that I want my X rotation to be, right? Whatever my camera pitch is, and I want to check it between my nadir, minimum, and zenith, my maximum. Does that make sense? So this utility method is going to return a number that's going to be between those two values. It won't allow it. If I go to the max, if I go beyond the zenith, it'll give me the zenith. And if I go below the nadir, it'll give me the nadir, right? Let's see if that works correctly, like I think it's going to work. If not, I can do some if statements. And we can make that work that way as well. So as I push up and I look down. Notice I'm looking down now, and I pull up, and I'm looking straight up. Now you can't tell because we have no other objects on the screen. But right now, believe it or not, we're moving around. I can move around the screen, right? I can travel. I can look up. By pushing down, when I push down, I look down, and when I pull back, I look up. That's unnatural. That's the inverted look that I was talking about. This, if I pull up, if I push up, right, then I should look up. That's what I should be, right? And if I pull down on my mouse, right, I should look down. And I'm doing the other way around, which means I got to invert my mouse again. Let's try this out. So we're almost there. Then we're going to add some objects so we can see some perspective. Otherwise, we can't see anything, right? So let's try this out. Let's. Here's my math clamp. So this looks like it's working, right? But what I want to do is, for my pitch in yaw, right? Remember we did this minus mouse controls yaw? Well, that doesn't make any sense. I want to kind of fix that up here. And I'm going to go back to my mouse controls. That's where I should change everything, right? So here's my mouse control. And where I have the positive event, I'm going to make it negative. Oops. But both these values should be negative, right? I could also multiply it by -1, whatever you want. It's just the way our orientation works. Okay, so let's try this again. So again, if I move to the left, right? I'm moving to the left, move to the right. I move to the right, look up, look down, I look down. So it looks like my mouse is all working. Let's add some additional things, you know, into our project to make it more interesting. Hey, we haven't done this until now. Well, what the hell? Let's add, instead of making it the kind of material that we've been using so far is a Lambert material. What I want to do now to make it more interesting is let's use a Phong material and let's add in a texture, right? Which we haven't really done before together. So how do we do such a thing? Well, first of all, we have to acquire a texture. But before we do this, just so that everyone's on the same page as me, so you see what I have, I'm going to upload to GitHub. That's the right thing to do. So I'm going to say completed mouse controls, right? Completed mouse control or mouse control movement. Go, and I'll push it up to GitHub. So please kind of compare your stuff with my stuff in order for us to get there. Remember, we changed our mouse controls object as well as our game.ts. We actually split off, you know, part of the stuff that we found in our game loop into its own function in order for it to work, right? That's what we've done so far. But I want to add some additional things here. And instead of us finding your textures on your own, just to mirror what I have, I'm going to drag and drop some stuff that I already have that I've downloaded from another project into our projects. Now, in order for me to do that, I want to keep very structured. So I'm going to add an assets folder to our project. So I'm going to kind of go down here. We haven't done this before. I'm just going to go to the plus button here and add a new folder called assets, right? And under assets, I want to add in a new file, right? Or a new folder again. New folder called images, lowercase. So uppercase assets, lowercase images. And by the way, the style that I'm using is very common in terms of, from a Microsoft perspective. Microsoft does the folders on the root are usually capitalized. The folders inside the root and or subfolders are lowercase. Again, at least that's some of their patterns. Okay, so that's cool. I mean, I've got this stuff. I need some kind of, in order for me to do some textures. Remember what I need is, I need to have a texture, an image that I can apply as a texture. I'm going to grab that image, cobble, gobble, cabble, gobble, whatever the hell it's called. Let me see what it is. I've got it from another project that I was working on, my sample project. I'm just going to drag and drop it, and then I'm going to update it up to GitHub so you can grab it. I'm also going to add in some audio. Might as well just add those in too. So I'm going to actually grab my audio and my images. Let me just grab those two things. Let me just delete my images for a second. Delete that. And I'm going to add in the other two assets in there, so that way not a lot of work for you guys to do. You can just have the images. By the way, I borrowed the audio footsteps from Unity, just so we have some kind of idea of landing, footsteps, and jumping, all that kind of stuff. You can certainly use other footsteps as you will, but I'm just going to grab those and let's add them in. Add them into our project for a second. Bear with me while I do this. So I'm going to go into 9 here under assets and it's. All right, so I've got images and audio, and what I'm going to do here is I've added some files, 8 files. I'm going to add them all in, and I'm going to say added image and audio assets. We go for this little example project, and I'm going to go to push them up online. So you'll have them in a second. So please grab them from there if you want to do what I'm doing. All right, so I've pushed them. They're up on GitHub now in that project. So you don't have to find different aspects just to save time. All right, so I've got my audio and I've got my everything else. I'm going to be using the Create.js library for audio because it's easy to do audio with Create.js. We'll talk about that in a bit. But my first piece that I want to take care of is I want to change some of the stuff I'm using from my ground, especially from a material that I'm using to a Phong material, right? So let's go back into our scripts. And I'm going to go zoom back out here to where my player is defined. And notice that my player is using a Lambert material with a color of green. And in my ground has this weird color of this burnt orange that we kind of used before. I need to change this. I can't use the Lambert material anymore. I'm going to make it so it's a Phong material. And let's check to see if I have it defined. So if I don't have a Phong material defined, I have a Lambert, a mesh basic material, line basic material. Let's add a Phong material. Remember, a Phong material gives us the ability for us to have specularity in there as well. So import, I'll call it Phong material, which will be like a 3 Phong mesh Phong material. That's what it is. Just to make it so that there's a bit of, saves us some space. By the way, I've seen other people who've done the same idea, and they've really reduced this down to basic, basic material, line material, Phong material, Lambert, and so on. Even if they even go so far as to make it Lambert or Phong, that's fine. As long as it saves you typing, that's important. Okay, so I've got the materials in there. For my imports, if I go back down to where I put my ground, notice I made my ground material a fizzy material, so that's not going to really affect anything. I can leave it as is. So I've declared as a generic fizzy JS material. That's good. But if now where my changes come into play is here, where I go to my ground material. Okay. So I want to declare a texture. One thing we don't have is we haven't declared any kind of ground texture. I'm going to make that up now. So underneath where I have my ground, around where I declare all my ground variables, let's do another one. I'll say ground texture. Here's my ground texture. And what is it going to be, right? Well, it's going to be a new Create.js.texture, right? That's what it's going to be. I could leave it that way, but I know I'm going to need more than one of these, which means coming back up here, I might as well create an alias for it. So let's, just like I had a material, I can do something like this. I can say texture is equal to 3.texture. I'm going to define a basic texture. Now I can go back down here where I have my ground texture and just call it texture after I've created my alias. Yay. All right. So now when we come down to our ground material, before I define my material, I want to get into what the texture is going to look like. So I'm going to say ground texture, right? And this is where it kind of gets funky with 3JS. You have to do a new, this is the new way of doing it, 3JS 3.texture loader in order for you not to use the deprecated method, right? Dot load, and then you're going to go up a couple of steps, right, from a pathing perspective. And by the way, we should probably do this, create a base path eventually, and then add to it. Images, and we call this something called gravel cobble. That's what the image path is called. .jpeg. That's what I added in there. Notice how it's texture loader.load. That's the new method. The older method is load texture, right? Again, we're going through different versions here. So the book will say load texture. Here it's, you know, texture loader.load, right? That's the new method. Okay, once you've done that, I want to create how I'm going to wrap the texture. So that's the next thing I want to define. So I want to say ground texture, and there's two wraps. There's wrap S, right? Wrap S, and we're gonna use a generic 3 repeat wrapping, right? And ground texture wrap T, and do the same thing. 3 repeat wrapping. So that, we'll talk about that in a second, what that does. And what I want to do is I want to say ground texture dot repeat dot set 4 by 4. Talk about what all this does in a second. Okay? Just keep typing. Okay. So remember what we did before. Down here, we said we did this anonymous new Lambert material, right? That's what we did here. So we called this our ground material, right? But what I really want to do is I want to talk about this almost like this should be a ground physics material. That's what this is. This thing that we're defining here, right? Instead of a ground material. It's a physics material, right, that we're using. So let's rename it. I'm going to go back up to the top here where it says ground material. We're going to just rename this thing to, so rename symbol, so ground physics material. That defines our, our physics, ground physics material is what I'm calling it. I'm also going to declare a ground material, right? Just like we would. It's separate. That has nothing to do with physics, right? Like we normally would do. I'm going to say var ground material, which is going to be a 3JS material, right? Need that. I don't want to make it anonymous anymore because I want to add some modifications to it, right? So I did two things. I renamed my old ground material to ground physics material, and then I added a new variable called just ground material again, which I'm going to use. So I'm going to go back down to here, into my player, and I've got my ground material. Here's my ground material. Now it's my ground physics material is equal to this stuff, right? But here I put in this anonymous Lambert stuff, right? Which I'm not going to do anymore. So in here, where this piece goes right here, I'm going to put in my ground material. This is where it's going to go. But I need to define it first. So let's do that. So I'm going to say something like this. Ground material is equal to a new long material, right? That's the new thing I want to do. So that's what the material is going to be. Notice I don't put anything in here, no stuff. And in here, where I have my material, I'm going to declare this as my ground material as normal. All I'm doing is I'm swapping these two things out. So one's ground physics material, one's ground material, two different things. Okay. And what we're going to put in here for my ground material, we have to modify it now, right? We're going to say ground material map is equal to my ground texture. And notice how we're getting a bit of an error, right? Because map doesn't really understand, material doesn't understand map, but Phong does. So we have to go back up here. We defined everything. This is a nice idea we had, right? Ground material is just material. Yeah, it has to be a Phong material. You have to really specify, or else you can't do map on it. You can't add a map onto it, like this. Right? So our map, our UV map, that's what this is our ground texture. Right? That's what it is. Okay. This should be enough for us to see if we're going to have that ground texture work. So I'm going to save this thing, and if all things go well, if I didn't make any boo-boos, right, mistakes, I should be able to come back here, and when I click play, if everything goes well, I should have this really weird thing here. Okay? Notice that I can look up, but whoa, what's going on here? I can look up and down, and as I move up and down, I got this weird flipping thing going on. Woo! Yeah. Whoa. How come is that? Huh? So something's up with that. We're going to fix that. That's why I wanted to put the ground in place, because we couldn't tell to this point what was going on, right? I need a ground, something that's textured, in order for me to look at what I'm seeing, right? I can't actually look down further than this. So I know what my problem is. This is a 0. This is the 0th level, this minimum, right? Right now, what I'm looking at, like right now, when I'm down like this, that's as low as I can look. And when I look up, I keep looking up and up, all the way, so my back is breaking. I'm breaking my back here, right? I'm looking right over, and that doesn't make any sense. I don't want to be able to do that. I want to limit myself even more than that. All right. Huh? A box can't flip because I'm not moving my box. I'm moving my camera. All right. Let's try it out again. Let's see if that's true. So refresh. I'm falling. Right, I'm falling, boom, right? And then if I look up, oh, that's good. That's a little better. I was like, oh, somehow my box did flip. Okay. Well, that's not bad, eh? So I get a bit of stuff. My ground doesn't look like real ground, though, eh? It looks like an image. It's kind of cool, but not really. Let's walk across it so I can see that I'm walking across the ground now. That's a little bit more details, right, as opposed to what it was before, right? So I can jump. It's pretty cool, and I can look down, right, as I'm jumping. I'm pretty good, right? Let's try again. It's not bad, right? I can even, I can do it again. Right? Not bad. So things are okay. You okay too, guys? Everyone's okay? Same thing? It's because of our clamp that we're using. We're using a dampening, right? Right now, what's happening, and also it's shaking because I'm actually rubbing against the surface. Even if there's no friction, it's going to be a little bit of we're going to experience a little bit of shake here because of the way the physics engine is working compared to what we're used to. Don't worry about it. It's not that important. All right, let's do a couple things here. I don't like this. This is nice, but I don't like it. I want to create a normal map. Who knows what a normal map is? You guys all know, right? A normal map actually gives us what fake bumpiness, right? Fake bumpiness to this whole thing, right? I've already done it. I've already created it for us, right? And actually, if you think about it, if you go to the inside my images, I have something called Gravel Cobble, and I have another one called Gravel Cobble Normal, right? It's actually up online already. How did I get that? I'm not an artist, and I can't do that with Photoshop so good, but there is some really cool online tools. I'm going to click on this little thing here. There's an online tool that I recommend to you. It's kind of cheap and dirty. It's called normal map online, right? There we go, right? And it's at cpetri.github.io/normal map -online, right? cpetri.github.io. I got to give props to these people here that made this. Kind of cool. One thing that's really cool about this little normal map that these guys made, whoever this guy is that made it, right, is if I click on this one, I can upload my map. So let's say I want to upload the one that I have. I can swim to that one. So I can go to, for example, on my desktop, I can go to COMP392. I have my lesson 9, and I can go in there to assets, images, and I can look at gravel cobble, right, and open that up. This is my gravel cobble image up online, right? And what I want to do here is I want to create a normal map, and it does it all automatically for you, right? Now I recommend, and this is a kind of an example of that normal map. I can look at it and see how bumpy it is. That's really too bumpy for me, right? That's kind of a result of what it's going to look like when I do my normal map, right? That's too bumpy, right? And what you can do to reduce that is, there's a couple things. One is we can reduce the strength of the normal map, like way down, so it's not as bumpy, right? That's what I've done. You can change your filter type from Sobel to Scar. Again, that's a little bit more bumpy, right? But you can actually, it does a different effect, right? You can also change the blur or sharp, right? So I can notice I can change how sharp my object is or how blurry it is. I can change those kind of things too. And I can also experiment on different objects like planes. What will my plane look like if I have a normal map on that one, right? And I've done all the work for you with some basic settings, so you don't have to do it yourself. If you were going to do your own normal map, you'd have to experiment a little bit. But all you're going to do is going to layer two things on top of each other. You're going to have your regular image, texture, and then your normal map's going to be layered underneath it, right? And what it's going to do is going to be add extra shadows to give you the illusion of depth, right? Okay, so let's see what that looks like. And how do I load this up with Three.js? That's important, right? So I've already done this piece for my texture, right? And this is cool, right? But I need to add another variable here to take care of my stuff. And I'm going to go back up here to my variables in order for me to make my normal map work. And so here's my ground material as an example. And what I want to do is I want to make my ground texture. Here's my ground texture. But I want to add this in as a var. Another texture that I'm going to add in, right? It's going to be a different kind of texture. But it's going to be a ground texture. We're going to call it normal. Put that in. Ground texture normal. It's still going to be a texture. A ground texture normal, right? Yay. All right, and let's go down to my to where we see that ground. And again, you can choose any texture you like for your ground. Now, notice how I have my ground texture. Well, I want almost the exact same thing, right? But for my normal, right? So let's just do the exact same thing. So I'm going to kind of copy this whole piece here and paste it underneath. Let's make some with my ground object. It is now, not for ground anymore. And now instead of doing this, I'm going to say ground texture normal. That's what that is. Just replace these. They have to kind of match, eh? Just FYI. They have to all be the same. The one thing is different is over here, instead of gravel cobble, it's going to have to be gravel cobble normal, so the normal map that you're pointing to. So a different texture. By the way, you can do this with other textures, not just this as well. You can layer many textures on top of each other to create different really cool special effects. So I've got these two different textures. One is a regular, my diffuse texture that I'm using, right? Or my albedo, if you will. That would be a good name. The other one is my normal that I'm using right here, my bump map. Okay. And here I have, this is where I can apply it. I have my ground material is a new Phong material, and my ground material.map is the ground texture. Well, guess what I can do? I can do something like this. I can say ground material dot bump, and bump map is the one I want to use. Bump map is equal to this ground texture normal. which is like it's the normal map. And I just from testing, I found that if I did ground material bump map scale or bump scale, it should be something like 0.2. Right? That should be the scale that I want to use. And the reason why is because if you make it more than 0.2, then it's going to be too bumpy, right? It'll look a little bit too gnarled or ground, and that's not what I want. Okay, so let's go back and check this to see how it looks. That's nice, Tom, but what's the effect of this thing you've given us? Well, actually, what you get is, if I do it for you in a second, did it flip again? It flipped. Oh. There we go. I get this. Now you can't, it's hard to see, but actually I get a bit of more texture going on than what I had before. It looks a little bit more realistic than what I had. If you look at the actual ground, it looks like more cobblestones. More realistic. Here's something else that I found that when I was doing these tests. I don't know if you guys saw the difference there, but there is a bit of a difference. What I found when I was doing these tests is something else. My cube, if I was going to, let's remove my my object again, my camera, just as an example again, one more time. Let's remove my camera just 1 second, okay? So I'm going to all I'm going to do here is I'm going to do one of these, just comment this out, my player add camera, and down here inside my my controls, just to go back to the way we were before, so you can see our cube for testing. Here's my camera look. I'm going to take that out. I'm not going to do a camera look right now, right? And down where we have our camera, I'm going to uncomment these ones out, so we can get our camera back to the position that it was. Just for a second, because now we have our texture, and I want to see what that looks like. So this is what our texture looks like with the camera, right? Here's our cube, right? And this is what the cube would see when it's moving around. This is nice. I like this idea of the cube, right? So when we kind of move forward, boom, we move, and this is what the cobble. Notice that the cobble texture is being repeated, right, over and over again. And I've just set a repeat matrix of 4x4. You can make it repeat as many times as you want, right? So an example of this would be if I go back to how we did the texture, right? So we go back to this texture idea. So let's go back to our ground. Here's what our ground object looks like now. I've repeated both textures, both the gravel cobble texture and the gravel cobble normal, 4x4. Let's try a different structure. So let's try 8x8. Well, we want to keep this even as much as possible. And I'll show you the difference now. So take a look at now, and now take a look at it. So you can repeat the texture over and over again. Challenge is you're going to get these repeat lines, right? Because it's repeating in a pattern, yeah. Yes, you can, but it becomes like, this isn't bad. This is like more of a cobblestone looking thing. The thing is, remember, we're not going to leave it like this. And I have a very small texture I used. It's a much smaller texture than I've used before in Blender. What I recommend before is remember, we're going to put stuff on on the gravel cobble. There's going to be walls that we're going to put around, so it's not going to be as noticeable. That's all I'm saying, right? But I wanted to show you the scaling because I think the scaling is a factor. One more thing is this: our cube is nice, but it's a cube. Is my player or my character, does he look like a cube? Do I look like a cube to you? No. The answer is no. Usually I want a longer cube, a taller cube, than I am wide or long, right? So I want it on the y-axis, I want it to be bigger. How do I do that? Well, that's just rejigging my character, my player, instead of a 2x2x2, making it a 2x4x2, let's say, right? So we can kind of get the idea of a different scale, right? And that's kind of a little closer to what my character would look like, okay? There's a couple reasons for this too, by the way. It's going to be harder to flip this one, number one. And the other thing is that it's taller. So when I add my camera back to it, let's add my camera back now. So remember what I did to take my camera away? under my player, which is right just where I left, here's my player, I had commented out this player.add camera and put it back in now. And I'm going to go back into my, where I have my, in my check controls, and I'm going to put back my camera look so I can see it. I can look with my camera again. And then turn off my camera position and look at, and turn those off. Let's go back. And if I go back the way it was, it's going to look like this. So this is now what my character is going to look like. Right? And it's a little bit better. It's a little bit higher up, right, than where I was before. Because my camera is physically located higher up. Where does my camera get added, by the way, by default? I'm adding a camera, but I'm adding it somewhere to my character. Where's my camera added by default? Anybody? In the center. So what does my camera really look like? In Blender, if you were going to do that, you would see nothing, right? That's a really weird thing. Same thing with Unity. If you actually put a camera inside another object, you see nothing on the outside. Not so in 3JS. In 3JS, because of backface culling, our camera is physically sitting inside of our block, right? It's physically sitting inside there. And it's right in the middle. And to visualize this, I'm going to stop this and do a quick Blender tutorial before we pause, just to give you an idea of where our camera is sitting, right? So let's suppose I have my block right now. It's very similar to what we just done. 2 by 2 by 2, the dimensions. Let's make our Z dimension to make it the same as 4, right? Here's my Z dimension as 4. This is what my block looks like, right? And as I'm zooming in, I'm going to parent the camera to that. So how do I parent the camera? Well, what I want to do is, first of all, I move my three-dimensional cursor away. I'll press Shift-S to move it back into the center. So cursor to the center, there it is. And what I'm going to do is I'm going to take my camera, here's my camera, and I want to reset my camera all the way. So everything's going to be reset. So I'm going to go 0, 0, 0. 0, 0, 0. This is what it's going to look like effectively. Just to give you an idea of what it looks like. Let's make this wireframe. So, and again, just so that you can see what it looks like, imagine what is happening right here to the camera. Poor camera. Right? So 0, 0, 0. And let's go to this. Instead of this, right, because that doesn't make any sense, it'd be up on the Z about 90 degrees, right? So in Blender, so it'd be like, you know, sorry, scale, rotation, move that to like 90. Right? I meant on the X. Okay. That's what your camera looks like right now, right? Just to visualize what's happening, right? I don't know if you guys can all see that, but so if you look at the wires, right, of our box, our camera's right in here. Is that right? Our bodies don't look like this, right? We don't have like our camera down here, right? Our camera should be up here, theoretically, right? So that's where we have to move it. How do I move it? How do I move my camera? If right now my camera is sitting here in the middle of my body, theoretically, from a 3JS perspective, and I want to move it up to my head or closer to my head, where should I position it? This right now, if this is a four units, this is 4 units by 2 units, right? What position is this at? 2, right? It's in 1, 2, 0, right? 1, 2, 0, right in the middle. So I got to put it towards the top. I don't want to put it to the right to the top. I want to kind of put it towards the top, like around right here, right? This would be 4 right at the top. So I want to kind of put it around 3, right? That's where I want to kind of put it, right? How do I move my camera so that it's higher up on my character's head? Yeah, I could do that. Let's go back and do that in code so you can see the difference. So here I have my camera, right? So my camera is set up where I do camera.add, right? Over here, my player. I go player, blah, 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 camera.add. This might be a great place to do it right here so we don't forget. So I want to kind of do a camera move. right? So I want to do camera. How do I do it now or after I add it to the player? Like maybe I should do it right after the player gets added, because right now it's at 0, 0, 0, and I want to move it up 1, right? So remember, for the camera, it's at 0, 0, 0. The camera's at 0, 0, 0. The camera is not at 4, you know, or 1 and 2. It's not like that. The camera's world is the center of the block, right? That's where it exists. So relative to the camera, the local space coordinate system for the camera, it's still 0, 0, 0, which means I got to move it 1 up to 0, 1, 0, right? So let's do that. So we'll say something like this: player dot position. Oh, sorry, player. Camera dot position dot set to 0, 1, 0. That's all I'm doing. Let's take a look and see what the effect that has when we play. See? So now I'm a little bit higher up, right? And now here's the line. Take a look at the line. How come I'm seeing the line now, right? Because I'm way up, right? I'm seeing the line. This is my line because my line is not coming out of my forehead anymore, right? My line is coming right there. And actually, this is a great way of thinking about this. If this is my line, think about my line as some place where my camera is aiming, right? My camera is aiming now. Wouldn't it be nice, instead of that line, that we can have a reticule that we can have in the middle of my camera, right? And wherever that reticule is, right, that is where I'm actually aiming my gun, if I have a gun, or that's the center of my screen. And imagine if we can make our reticule a little brick, a little block, a little dot, right? So that we can look at it. Maybe a little colored dot that's yellow or something else, so we can look at it. Just like we're making this line that's yellow, right? Make a little dot that's yellow. And it's going to be what? I think I made it like a bunch of units out. Let's see how big I made my line. 50? I probably made it 50. Yeah, 50, right? Minus 50. How did I do that? How would you recommend that I make something that has no collision? So there's no collisions for this thing, right? But it creates a location in memory, a location in space, physical space. There's a couple ways to do this, by the way. That's out at 50 units away from my camera. But it's right in the middle of my camera's viewpoint. How do I do that? Anyone have an idea? How about the smart guys over here in the corner? Anyone have I want to use a flat surface, or how about the girls on this side here? I can't just always look at the guys. It's not fair, right? Right. So I want to make a little square that's sitting in the middle of my field of view that's yellow. What do I do? So think about it. Let's take a short break, and when I come back, we'll get it done. And then we'll add some sounds.